Okay, we are going to once again do an example of how to do a proof that involves angles. And as often is the case, this proof is actually going to be proving two lines parallel to each other. Working on proofs in a geometry class is a very important thing and is very useful for later math classes. This particular proof says if Jm is parallel to Kn, and you can see it, we've got the arrows on there indicating that on our picture, and 1 is congruent to 2, so you've got 1 congruent to 2, and 3 is congruent to 4. Then prove that Mk is parallel to Ln. That's our goal. And looking at this picture, you might first notice that those statements tell us things about the triangles, that the triangles actually are a specific type of triangle called an isosceles triangle. And you may be tempted to use that. However, in this particular problem, if I want to show that Mk is parallel to NL, I don't show things parallel by looking at sides, which is what you'd be doing if you were using isosceles. So instead, I just need to ignore that fact and look at the angle. So let's start our proof off and write down our given, which is always whatever the ifs part of a if-then statement is. And we get that as a given statement. So you got Jm parallel to Kn, L congruent to 2, 1 congruent to 2, and 3 congruent to 4. And usually our first place to start in a proof is to say, what does our given statements tell us? Now, sometimes it's a good idea to also maybe plan your proof out a little bit. And so if I look at this, to prove that Km here is parallel to Ln, then I need to know something about angles that are on the transversal, which is this. I either need to know that 2 and 4 are congruent because they're corresponding, or I could maybe show that this angle right here and 4 are supplementary. Well, I think it's going to be easiest to show that 2 and 4 are congruent because we got nice statements up here about angle 2 and angle 4. So that's probably going to be our best bet. In doing that, we look at it and see we got information about both triangles, but we need to find information connecting up these two triangles because we need 2 and 4 to connect up. And if you notice, well, you're given that Jm is parallel to Kn, so you should probably use that. Well, you can use that by showing that angle 1 is congruent to angle 3. And your reason for that is corresponding angle postulate, or I just have my students just go ahead and make the statement corresponding angles are congruent. Probably best if you were to actually write out that if two lines are parallel, then corresponding angles are congruent. But it's okay just for shortness sake to say just corresponding angles are congruent. It's implied the angles are parallel. Now, that's really good because we can utilize some connections here, and we can see that, well, I've got 1 congruent to 2 different angles, and so I can say that 2 is congruent to 3. And that happens using what is our ever-powerful transitive property of congruence. If 2 angles are congruent to the same angle, then they're congruent to each other is essentially the transitive property of congruence. Now, a couple of our students asked the question of whether you can do, because we're going to do, our next statement is going to be using the transitive again, and they asked if they could just put it all in one step. And my answer is no, because the second transitive property uses this statement and this statement didn't exist before this step. So we can't use a statement that didn't exist before that step in the step. So we need a new step, which just says 2 and 3, or 2 and 4 are both congruent to 3. So I can claim 2 congruent to 4, and that's by the transitive property of congruence. And then, as I talked about at the beginning of the proof, that is enough to make our claim. We can now claim that Mk is parallel to Ln, and that is because angle 2 and angle 4 are congruent to each other in their corresponding angles. So you say the converse of the corresponding angles postulate. And that's enough to prove that those 2 angles are congruent, or 2 lines are parallel. It's a good example of using that transitive property and using information about one parallel line to prove another set of parallel lines. All right.